Greetings to all our students. Before you is Mr. Innocent Kenny. From Nigeria. This is a UniApp online university course and the course code is MTH1101, which is General Mathematics 1. A 3-credit unit course. The course outline, although not indicated in this file, but it contains the following topics: elementary set theory, subsets, union, intersection, complements, Venn diagrams, real numbers, integers and irrational numbers, laws of indices, which is contained in this very document. Further, we have logarithms, polynomials, mathematical induction, real sequence and series, theory of quadratic equations, inequalities, binomial theorem, matrices, determinants and systems of linear equations, complex numbers, algebra of complex numbers, the Argand diagram, the Moivre's theorem, circular measures, and trigonometric functions. That is just the rundown of the course outline. The topic we'll be considering in today's lecture is indices and exponential equations. In mathematics, product simply means multiplication. For instance, someone says, what's the product of 2 and 3? It is simply 2 times 3, which is 6. Index form was introduced so that the product of equal numbers can be written in shortened form. The laws that govern the simplification of indices were also established, and that is what we'll be considering in this lecture. Definitions. Index form, sometimes called index notation, is a method of shortening the product of equal numbers. For instance, the product 2 times 2 times 2 times 2 times 2. That is 2 multiplied by itself 5 times. Is simply written 2 raised to the power 5. In this form, the number 5 is called the index, which has the plural as indices. Another word for index is power or exponent, while the 2 is called the base. So this index form tells us how many times the base is being multiplied by itself. I have given several other examples here. 3 being multiplied by itself 4 places, that's 4 times, it will be equal to 3 raised to the power 4. And 8 multiplied by itself 8 times, it will be equal to 8 raised to the power 7. We also have what is called exponential equation. This is an equation that has a variable in its exponent. Whenever there is an unknown in the exponent of any given equation, such is called exponential equation. There are several examples, such as 2 raised to the power x equal to 4, 16 raised to the power y minus 7 equal to 4 raised to the power y plus 2, and so on. After these definitions, we have the next subtopic, laws of indices. Law number 1. Let m and n be integers and a any real number. By integers, we are saying that the m and n can take negative whole numbers, positive whole numbers, or 0. That is what constitutes the set of integers. And a real number is a number that can be a decimal number or a whole number or a negative whole number. That is what the real number is. And even 0. So any number you can think of is a real number, provided it is not a complex number. So the law holds that a raised to the power m times a raised to the power n will be equal to a raised to the power m plus n. This law is sometimes called the multiplication law of indices. For instance, if we have 2 raised to the power 3 times 2 raised to the power 5, the answer will simply be equal to 2 raised to the power 8. How do you get it? If you add 3 plus 5, you get 8 as the power. Law 2. A raised to the power m divided by a raised to the power n will be equal to a raised to the power m minus n, provided a is different from 0. The base a must not be 0. If it is 0, the law might not hold. Therefore, 7 raised to the power 5 divided by 7 raised to the power 2 will be equal to 7 raised to the power 5 minus 2, which is equal to 7 raised to the power 3. Law number 3. If we check it, a raised to the power m is also raised to the power n. An index number also has a power. So to simplify problems like this, the law holds that the index the powers are multiplied, and the exponents they are multiplied, the indices are multiplied to give a single value. Therefore, a raised to the power m or a raised to the power n will be equal to a raised to the power m times n, which is equal to a raised to the power mn. Law number 4. A over b or raised to the power m will be equal to a raised to the power m all over b raised to the power m. Both the numerator and the denominator are each raised to the power of m. A similar law follows with law number 5. A b raised to the power m will equal to a raised to the power m b raised to the power m. What does that mean? AB means A times B. If both are raised to the power m, to solve problems like this, we raise the first value there, which is A raised to the power m, times the next value raised to the power m. If they say another value, you keep raising each to the power m. Law number 6. A raised to the power 0 equal to 1, provided A is not equal to 0, is different from 0. Because 0 raised to the power 0 in mathematics as it stands now is said to be undefined, said to be meaningless. Law number 7. So for instance, for law number 6, any number raised to the power 0 is 1. That is what it means, provided the number is not 0. So 10 raised to the power 0 is to be 1, 5 raised to the power 0 is to be 1, 2 raised to the power 0 is to be 1, 1 million raised to the power 0 it will still be 1. Law number 7. A raised to the power minus m will be equal to 1 over a raised to the power m. The minus m, the negative power is changed to positive power as we introduce 1 over. Law number 8. A raised to the power 1 over n will be equal to the nth root of a. And in general, a raised to the power m over n will be equal to the nth root of a, or raised to the power m. And finally, the rule number 10 states that if x raised to the power m is equal to x raised to the power n, you see that the bases are equal, but their powers are different. Then the powers must also be equal, provided x is greater than 0, that is, the bases are greater than 0, and the bases are different from 1. And the examples follows. 6 raised to the power 3 times 6 raised to the power 4 will go to 6 raised to the power 7. How do we get 7? Because 3 plus 4 is 7. That's multiplication with the first law we applied. The example 2, what I also applies. We applied law 1. 2 a raised to the power 2 times 3 a raised to the power 5 will equal to 2 times 3 give us 6, and 2 plus 5 will give us 7. That's how we got that 6 a raised to the power 7. 27 y raised to the power 10 divided by 9 y raised to the power 4 is the same, which it will be equal to 27 over 9 will give us 3, and 10 raised to the power 10 minus 4 will give us 6. So let's simplify it. We have that 3 y raised to the power 6. 2 a raised to the power 3, and the next example will be equal to 8 a raised to the power 3. How do you get 8? Because 2 raised to the power 3 is equal to 8. 2 raised to the power 3 is the same as saying 2 times 2 times 2. 2 times 3 is 4, and 4 times 2 is 8. And then a raised to the power 3. Each term in the bracket is raised to the power that is outside. The same thing we did in the V. Then for the VI, 16 raised to the power 3 over 4, we took the fourth root of 16, which gave us to 4 raised to the power 3. That is what gave us the 8. The next example, 3 over 2 all raised to the power minus 2. There are various ways we can do this, but a very simpler way is what I employed here. The negative power is changed to positive power. To achieve that, we have to move the numerator to take the place of the denominator, and the denominator to take the place of the numerator. As the values are in the brackets, they will interchange their positions. The one up goes down and the one down goes up. That is what to do if we are to change the negative power, which is minus 2, to the positive power, which is 2. Next, we apply the foot law. Each term there is being raised to the power that is outside, power of m. So we have 7 raised to the power 2, which gives us 49, and 3 raised to the power 2, which gives us 9. When simplified further, you have 5 whole number, 4 remainder, 5 whole number, remainder 4 over 9. If you divide 45 by 9 and expressing your number as a mixed fraction. Example 2. 13x to the power 0 plus 13x power to the power 0 to give us 13 times 1 plus 1, because any number to the power 0 is 1. 13x power to the power 0 will give us 1. So when we multiply 13 by 1 and adding to 1, we will get 14. That is how we got the answer to that question. The next one, we express 0.01 as a fraction. To achieve this, what did we do? Where there is decimal point, we put 1 there, and below the 0 and 1 we put zeros. Below other digits we put zeros. So you draw a division line. Below the 1, below the decimal point you put 1. Below 0 you put 0. Below 1 you put 0. If there are extra digits, you keep putting zeros until you get to the last digit. Then that will be equal to 1 over 100. The zeros in front are deleted. Or raised to the power 3. 1 raised to the power 3 is 1, and 100 raised to the power 3 will give us 1 million. Answering the given question. Next is simple exponential equations. To solve exponential equations, we apply the 10th law of indices as stated above. That is, if x raised to the power m is equal to x raised to the power n, then m is equal to n. The powers have been equated. I've applied it here in example 3. If we are given 4 raised to the power x equal to 16, we have to establish equal basis. Once that is done, the powers are equated, and the resulting equations are being solved to determine the unknown. That's what we did here. The 4 and the 4 on the left hand side and the right hand side will cancel out, remaining only the powers that will be equated and solved. So this is a simple example. That is how we got our s equal to 2. If you want to check whether your answer is correct, 4 raised to the power x in the place of x put 2, the 4 raised to the power 2 will give you 16, which is correct. So this will be the end of today's lecture. In our next lecture, we will give further examples to illustrate how simple exponential equations are solved, and then the assessment will also be given which will be 15 marks to be submitted in 3 days time, 3 days interval. And oral topics will follow. We draw the curtain close. Keep studying hard. Where there are questions, my WhatsApp line is 081 527 360 48. Nigerian line +234 81 527 360 48. My email address is inibisentini@gmail.com, and my Facebook username is Vincent. Thank you very much. Hope to meet you in the next class.